Darwin's picture of how life works, what's going on there, was different than what came before. Instead of having lots of independently formed or created things that were all separate, he proposed that there was just one big genealogical family tree of life, and everything is related on this tree, including us. He uncovered fossil extinct creatures in South America, and he saw bizarre living things all around the world. So by the time he returned, he had experience that few people who have ever lived, even today, could match in terms of how much of life on Earth he had personally witnessed and collected and examined. And what he learned was we fool ourselves by surrounding ourselves with our civilization. We think we're so different. We've left nature and everything else behind. But it hasn't gone anywhere. It's right there.
What if everything you think you know about the world was proven wrong? Today we are talking about Charles Darwin, a man who revolutionized our understanding on the origin of species. To help us understand the legacy of Charles Darwin's work, we have with us today Professor John van Wyhe. Professor John founded Darwin Online, the world's largest and most comprehensive online archive of everything Charles Darwin related. He is also a leading expert on Charles Darwin's life and scientific contributions. He is currently a senior lecturer at the National University of Singapore and is focusing on teaching the history of science to the students that come through NUS. Perhaps it might be useful to first understand what was the dominant intellectual climate back then, pre-Darwin. How did people think about the origins of species back then?
It's not like you usually hear in the media or documentaries that before Darwin, everyone thought that God just made all the species in 7 days and that's the way the world had always been. That's not actually what people thought just before him. The sciences were already pretty advanced, especially geology and paleontology, so they knew about the fossil record really well, that millions of species had appeared and disappeared over and over again. So everyone accepted this. They just didn't accept that they had evolved one from the other.
Yeah.
They thought that, well, probably that's just been lots and lots of creations. Every time a new island arose in the ocean, somehow new species were created to fit it, to live there. And then they started to think that, well, maybe God creates the species in a natural way, just like mountains rise and fall with natural means. The planets go around because of laws of nature. So maybe species form in the same way. So no one was doubting that God did it, but maybe it's not directly. Maybe it's through the laws of nature, like so many other things. That's the state of thought just before Darwin comes on the scene. And when you put it like this, it's not that radically shocking, is it? Whereas if you present the story as everyone thought it was just like in the Bible, and then Darwin came along and, oh, what a mess. Well, that didn't really happen. Certainly not for educated people and people in the scientific community. They already knew that living things had come and gone millions of times. But they really didn't like the idea of evolution. And what Darwin did was he convinced the scientific community that, yeah, okay, it's a fact. It really did happen. It really is happening.
Why didn't they like the idea, or why were they not welcome to the idea of evolution?
Well, there's two main reasons. One is that they really wanted God to be involved, to be actively in charge and intervening in nature and creating the butterflies or whatever. And the second one is human beings. People in some parts of the world really hated the idea that we could have come from animals. That was really the strongest one. No. Interestingly, if you take a global perspective and not just a Western perspective, peoples who live in parts of the world where there are apes and monkeys that have historically not had a problem with this idea that human beings come from apes. Whereas people who live in parts of the world where those animals are not from hate the idea and are very offended by it. I don't know why that is, but that's a fact as well. Everywhere in the world where you have apes and monkeys, so there'd be Africa and Asia. So I'm talking about the traditional communities and ethnic groups who actually know these animals.
Yeah.
It wasn't often they had folklore and traditions that they came from them, or they had a tradition that the apes and monkeys came from humans, and say a group of people had gone into the forest and degenerated and become the monkeys. So there are all these stories and myths of that kind. So the Darwinian idea wasn't so shocking to such people.
You remind me of that story in The Journey to the West. That's the classic tale in China where they have the Monkey King who is kind of anthropomorphized, right, into a human. There is kind of a perhaps familiarity with humans and monkeys being similar in that sense. If we were to think about Darwin's Origin of Species and his theory of evolution, what did he specifically posit that fundamentally reshaped the way we think about ourselves?
Well, I would say that Darwin's picture of how life works, what's going on there, was different than what came before. Instead of having lots of independently formed or created things that were all separate, he proposed that there was just one big genealogical family tree of life, and everything is related on this tree, including us. So just as dogs are related to wolves, we are related to the other apes. And it was a very simple and consistent idea. But of course, to people who are accustomed to thinking that human beings are completely separate from animals and nature, that's one thing, but the human world and human beings are completely different. And the implications of Darwin's theory are clear. Well, human beings are just animals too. Well, that's, depending on who you're talking to, that's either okay or no, we're not. It depends. So some people found that very unacceptable, very shocking. Some people still do.
You're the world's leading expert on Charles Darwin. You have this comprehensive web archive online, Darwin Online. You collect all his works. What kind of experiences molded him when he was young that kind of set him on this path of being a naturalist and what we call a scientist today?
He himself realized that it was somehow an innate interest in nature that he had, and that he liked to collect things. Whereas his brother and his sisters grew up in the same household and they weren't interested in these things. And so as soon as he went to university, he got into what we would call biology. It wasn't something you could actually study back then. There were no science degrees yet. But there were people who were already very advanced in studying plants and animals. So he straight away went into pursuing this and became very proficient. So it was clear that even if he was going to become either a doctor, was the first idea, and the next idea was that he become a man of the church. But even if he had, he still would have devoted his life to science, as did his cousin, who joined the church, but also spent his life working on science. That was really common back then. It was his personal interest and passion. Right? If someone has passion for a subject, well, maybe they'll go really far. If you just have to do it, it's hard to motivate yourself.
Do you think that was an obsession?
Sure, obsession is absolutely a fair word to use. Yeah. For example, a time when he was a student in Cambridge and was collecting beetles, and he was competing with his fellow undergraduates to get the best collection and to get the really rare ones that no one had ever seen. And one day, he saw one that was really rare. He grabbed it, and then right next to it was another super rare one. So he got that one too. And his hands were full. And then he saw a third and super, super rare one. And he didn't want to let them go. So for some reason, he popped one in his mouth to grab the third one. The one he put in his mouth had a defense mechanism and shot some kind of acid into his throat. So he coughed it out and he lost all three in this mess. Now that's somebody with passion for collecting and for their hobby.
I think you remember this episode until his later years, and he regretted losing those three even in his older years, right?
Right.
So what in Cambridge kind of encouraged him to pursue this? Was it the academic environment that shaped him?
I think it's really like it is today. There were the academic studies, things you had to do to graduate. Then there were lots of other things that were possible. if you were interested, you could pursue lots of things. So 3 years in a row, he took the botany lectures of Professor Henslow, who he really admired. This man was just so brilliant. He seemed to know everything. And Darwin became quite close with him, and he learned a lot about science from him. So as a young man, he's aware that there's so many books and articles being written on science and on the things he's passionate about. So he knows there's a world he could move into. And now he's got his foot in the door at university by meeting some of the big players. And that's really exciting. And although he's a beginner, he's welcomed. And that's just the beginning.
Following which, he went on to this voyage, the journey of the Beagle. And that was where we started to see Darwin kind of come into his own. Could you help us understand, or maybe contextualize, how did this journey on the Beagle shape his thinking that would eventually lead him down to his original species?
The voyage of this ship called the Beagle, which is a type of dog, but it's just the name of the ship, was assigned by the Royal Navy to go around South America and then around the world to make a higher standard of maps than existed already, to chart the coastlines super accurately. Their maps were so good, they were in use for over 100 years. They found every submerged rock and so on. And the captain thought it would be a good idea to take along a naturalist to study the nature of all those remote places they were going to visit. And it turned out to be Darwin. And he was very well qualified. He just graduated from university. He studied sea creatures at the University of Edinburgh. He studied botany, insects. He's very good at shooting and also geology. He's very proficient. I mean, he was remarkably well qualified for someone to take along to study all of the natural world where they were going, because he really could. He had the experience and the competence to study things from microscopic sea creatures to giant fossils, and he collected the lot. So over the course of 5 years, he uncovered fossil extinct creatures in South America, and he saw bizarre living things all around the world. So by the time he returned, he had experience that few people who have ever lived, even today, could match in terms of how much of life on Earth he had personally witnessed and collected and examined. But amongst all those things he collected were a lot of weird puzzles. A lot of things that didn't make sense, like things that are normally sea creatures, but he found a version living on land in the forest. So what? How does that work? Or birds that can't fly. Why do they have wings? Or birds that have webbed feet, but never touch water. Why do they have webbed feet? Webbed feet are for swimming. And the fossil bones that he discovered in South America turned out to be types of animals that only live in South America today, but long, long ago, these giant ones lived there, and that family only lives there today. Well, why should that be? Is there something about South America that makes armadillo-like creatures be created there? And it was already found that in Australia, ancient extinct types of kangaroo had lived there long, long ago, in the place where kangaroos famously live today. And it was all of these puzzles, and of course the Galapagos Islands, which he knew as a geologist, those just erupted out of the sea as lava. Nothing lived there. Now you come back after a long time, there's lots of plants and animals there. Where do they come from? That's what the phrase origin of species means. Where do they come from? What's their origin? And the earlier theory would have been either that they were created or somehow formed from nothing. And Darwin realized there's no way. They're so specific in their details. The creatures that live in Galapagos look a lot like the things in South America nearby. And yet they're not the same. There are new species there. So that's what led him to the idea that they must have been descended from things that came from South America and changed. And then once he had that put together, the whole fossil record picture makes sense. All those different species through time that gradually look different because they've descended one from another with lots of extinction and lots of dead ends. little branches of a family goes off one way or another and then they die out. But everything that's alive today is descended from ancient ancestors. And this explains something fundamental about life on Earth. You've got groups of plants and animals that look really similar to one another, like the myna birds here in Singapore. You've got the common black glossy one we usually see at the hawker centers. But amongst them, there's another kind that looks really similar. It's got more of a yellow a skin patch around its eye, and they're not so shiny black, they're more dull colored. That's called the common myna. Those are two species of myna. So that kind of thing of having species that are really similar and others that are very far apart. Darwin's theory could explain this, why this exists. Why are there some things really close and some things really far apart? And it's from the branching tree of life. Things that whose ancestors have branched off not that long ago are still similar, whereas things whose ancestors branched off a really long time ago have accumulated a lot more differences, and that's why they're so different. So even amongst, well, say mynas, or any family of plants or animals, that is true. You'll find some that are really similar and some that are way off. And then you can zoom out, and the same thing is true for all of life. That you can see the relationship between a puppy and yourself. Our last common ancestor was a really long time ago, but our bodies are extremely similar. The cells, the chemicals that we're made of are identical. The blood vessels and the nerves run in exactly the same pathways. We have exactly the same skeletal bones in the same arrangement. All of those similarities can only come from the same ancestor.
Yeah, many tangents to explore here, but it might be useful to kind of understand the process in which we call natural selection. So Darwin's theory was that there was a kind of natural selection at play. But if we were to kind of dissect the word natural selection, what does it actually mean?
This has been endlessly confusing ever since Darwin published this phrase, natural selection. It is an analogy with what farmers and breeders do when they select which one will they breed from and which ones they don't, which ones they'll eat. So for example, if you keep chickens and you keep them for egg production, some birds will lay 6 eggs a week and others 4. So you will choose to breed from the ones that lay the best eggs or the most eggs or both and not those. So by selecting, farmers and breeders really actually change living things right now. They change sheep, they change peas, they change whatever it is they work on by selecting the features to continue and the features not to continue. So more eggs or more fat in the meat of the cow or the pig or whatever. So whatever it is about organisms, by choosing, they accentuate that over time. And Darwin's natural selection means the same process happens in nature, except without a farmer or breeder selecting. In nature, it's simply survival versus death. And this is the confusing thing for so many people. Nothing is deciding, and there isn't a force or power in nature called natural selection. And even great biologists make this mistake by referring to natural selection as a force or power in nature that's doing something. Yeah, metaphorically, okay. But when you're talking to people who don't know how this works, I think it's not useful to use a mistake like this. It's a myth. There is no force or power called natural selection. It's Darwin's name for whatever in the world makes a difference to things living or dying. Now, obviously, that's a huge range of things. It can be drought, starvation, disease, predators, being too short or being too green. If you're living in an environment as a bug where it's quite brown and one is born a little bit too green, it's probably going to get seen and eaten. You know, all of these things are called natural selection. So it's not really a thing.
Yeah.
It's just a label, a very convenient and useful label, but we have to constantly remind ourselves that it's not actually a thing itself. And everyone falls into this mistake, including me, that you just talk as if there's something doing it called natural selection. Another metaphor that Darwin maybe should have used is a filter. So the process of natural selection is like a filter that lots and lots of things are born. Say like all the pollen in the air, that's all little living things that could grow into plants or not. See, most of them don't. The vast majority never make it through the filter of death. They die. They leave no descendants. So of all the things in the world that are alive, their ancestors have passed through the filter. So there's every generation you get a new crop of things born or hatched, and they're all slightly different, and they all get blocked or get through that filter of death. So things are constantly spreading out in terms of being born differently and varying. When you see an organism that looks the same, that's natural selection too. People only think often that evolution just means a giraffe's neck getting longer or something dramatic like that. But even things staying the same is the same process. It's also evolution. So if some bird species stays the same on an island for a really long time, that's because all the ones that are born that vary away from that normal form aren't making it. They're being killed off. They're not surviving. So that's the same process. It's simply what gets through the filter of death. Are they fast enough? Are they the right color to survive? They'll make it. If not, then they don't. And this constant filtering or winnowing out of forms is what either keeps things the same or sees them gradually change in some new direction. So there's nothing in control, just this filter of survival.
How then do we make sense of random mutations? Or mutations that we see in the natural world every day?
Yeah, mutations happen all the time because of the complexities of cells and molecules. So they are extremely common. My students are often very surprised to learn that most of the people you know are probably a mutant. As we've all watched the X-Men films, and those make a very big mistake when they refer to the mutants versus the humans. Well, that's just nonsense. That's not how it works. A mutated something doesn't become a new species. That process would have to go on for 100,000 years of continuous change. Then you might call it a new species, not just something is born different. That happens every second of every day on this earth, that things are born with mutations. But most of them are so tiny that they're not noticed. And often, usually they make no difference because they're just so tiny and so random, and they mutate. Things change in every possible direction. But this filter, as I said, will either not let something survive if it's too different, if it's not helpful, the mutation is not helpful, or if it's a mutation that actually turns out randomly that mutation works well, then it will get through the filter of death. So, for example, if we have a beetle living in on brown rocks, and some beetles are born with a slightly differing shade that doesn't camouflage well, they're not going to make it. Whereas if one is born whose shade matches the color even better, then that one is likely to survive. So when we come along and we see some insects that just so perfectly match the background, we can't believe it. They look invisible. We think, how did that happen? This is how it happened. Because little variations, including mutations, happen continuously. So there's always all this variation that could go in one direction or another if they survive.
And as long as they survive, these traits propagate, essentially.
Probably. It's all probabilistic, and it's all relative. So the old-fashioned idea of survival of the fittest is also not a good shorthand for Darwin's theory, because sometimes it's survival of the slowest, sometimes the stupidest. It's just relative to where it is. So, for example, sometimes an organism doesn't get more complex. Sometimes they get simpler. Like cavefish losing their eyes. Now, fish with eyes that's swimming around in the sea, that's a really advanced organism. They have excellent vision and so on. Whereas one with no eyes is a lot simpler. But this has happened thousands of times in the world, that fish have found their way underground and they lived there for thousands of years in the dark. They're the same fish that came from outside, but now they're locked down there in caves. Every once in a while, a fish is born without eyes. Everywhere. Everywhere that happens. I'm sure it's happening this second because there's so many fish in the world. A fish is being born without eyes. But in the ocean, well, they get eaten. But in the cave, when that happens eventually, that fish has an advantage because eyes are a very costly organ to feed. It takes a lot of food, a lot of calories to grow this complex organ that has a lot of different chemicals in it. It takes a lot of energy just to maintain that organ. And in the dark, it does no good. So the one born without eyes is living in a community where all the others have eyes. That one has an advantage now. So it's likely to survive better and have more offspring. So again and again in the world where we find fish in caves, in different parts of the world, it's happened independently many times. They don't have eyes. And that's how.
So the word fittest in survival of the fittest could maybe be retrofitted to survival of the best fit, I suppose, to the environment.
Sure.
Is that what we're trying to get?
Yeah. Some people say it should be survival of the luckiest. Darwin himself, when he saw how many problems people had with these expressions, particularly natural selection, he said, maybe I should have called it natural preservation, which is actually quite good. In other words, the things that vary in a helpful way for that living thing are likely to be preserved or just not die until they reproduce.
You noted that he was an excellent geologist as well. And what were the kind of groundbreaking work that he did on his voyages that helped him or helped us understand how even the world was formed?
It's something seldom remembered today that he was one of the world's leading geologists. He just left university, he went on this voyage, and he had amazing opportunities. And he discovered things like the southern part of the South American continent has been elevated up out of the sea multiple times over millions of years. You can see this when you're at the shoreline. Of course, there's a beach where the waves have been rolling the stones for thousands of years, and all the stones are nice and rounded. All the jagged edges are gone, they're pretty smooth. But as he goes inland, he finds the land goes up on a sort of plateau, and those sort of stones happen again. That's the remains of an old beach where the sea washed there, but it's now 100 feet up. And then further inland, he found another plateau. So step after step after step, showing that the land had been repeatedly elevated, and then for a long time the sea eroded away, and then it got wrenched up again. So there he had a sort of continental, almost global evidence of how the surface of the earth is gradually changing. And then in the Pacific, when he got to the coral islands called atolls, which are just made of coral rock. There's no other kind of rock there. There's no volcanic rock. And that was a big mystery. How are these weird things shaped or formed? They look like giant donuts in the ocean. They're sort of ringish shaped, bumpy rings. And they're flat. There's no mountains. It's just coral rock. And there's a reef all around it. So it's just coral reef. Where did these coral reefs, how do they make islands? Because how could they make islands when coral can only live at this shallow depth at the surface of the sea where there's bright sunlight? And yet the ocean floor might be over 1 mile deep down into the darkness. The coral reef could not grow up. It could only grow up here. So the theory before Darwin was there must be a volcano that was erupting under the sea and then stopped and died and cooled just under the surface. And then the coral reef came and grew on top, which is a very good theory. And Darwin thought, there's so many of these volcanoes have all stopped at just that right distance under the surface. That seems a bit implausible. And when he was in Tahiti, which is an island with a coral reef around it, he saw the island next door. I've been there. I've stood in the same spot and saw what Darwin saw. And very rarely back then, before before planes. He had an aerial view of the island next door with a reef around it and a lagoon. And with his understanding of geology from South America, the surface of the earth goes up and down gradually. What if that volcanic island in the center of the reef were to gradually go down over millions of years, and the reef can grow up? You would be left with what? No more island and just this big ring. And that was his first great scientific theory, that how these coral atolls are formed. And he was right. After World War II, when they were testing atom bombs in the Pacific, they needed to drill through some of these coral islands to find out how far down is the volcanic rock, so that they could test with, how the blasts were working. And they drilled through coral rock for 1 mile, over 5,000 feet, before they hit the volcanic rock of the island that used to be there. Because the seafloor in that part of the world is gradually sinking, just a few millimeters a year. And the coral can grow up a few millimeters a year, so it's just maintained its position while the island it was originally surrounding is gradually sunk. So that's an amazing discovery for someone in their mid-20s to make. But also, it's so eerily similar to his theory of the evolution of life. A really slow, gradual process, which is simply adding up teeny tiny things that in themselves you never notice they're so tiny. But with enough of them and enough time, enormous change can happen. So if you're standing on one of those coral islands today, or live your whole life there, you won't see any of this because it happens on a timescale of millions of years. It's just moving so slowly. But you can put this together.
I think there is an age-old debate over nature, over nurture, or how much does nature impact the way we evolve or adapt as human beings. Can you help me understand how did Darwin approach this nature over nurture kind of debate or discussion?
So these 3 young people from Tierra del Fuego had been taken back and taught some English, and they tried to teach them Christianity. And they thought if they take them back to Tierra del Fuego, that then they'll spread this, and also they would leave a missionary there. And then they thought that they would leave behind a people who would be friendly to any shipwrecked sailors in the future, and so on. So what shocked Darwin was that when they got to Tierra del Fuego, the place was so wild and remote. There are no cities for thousands of miles, but people have been living there for thousands of years. But their houses were just piles of sticks, and they walked around almost naked with animal grease on their skins and maybe various colored paints and so on. So they shocked Darwin by seeming so animal-like because they had a very primitive lifestyle in one of the harshest places in the world. So they left behind these 3 westernized ones, and after a couple of weeks they came back and they had reverted to the local customs. They were basically almost naked again. The hair was all messed up. The polished shoes were gone. The clothes were gone. And this shocked Darwin to realize that the way everyone back home saw things about what civilization is and so on is not really true. It's just a paper-thin veneer on top. And it's not really any deeper than that. In other words, civilization and how different we feel from nature and so on. If you're living in an air-conditioned shopping center, nature seems very far away. And what he learned was we fool ourselves by surrounding ourselves with our civilization. We think we're so different. We've left nature and everything else behind. But it hasn't gone anywhere. It's right there. As these people had thrown away all the trappings of civilization in order to live in that environment again when it was necessary. It was one thing to dress and act one way when you're in a city, but when you're living on the frozen tundra of this windswept, icy cold place, a different way of living is necessary. And so they had reverted to the look and the lifestyle of their families and their communities. And yeah, it was very shocking because he had never seen people like this. And indeed, no one today has ever seen people like that because they don't exist anymore. They sadly succumbed to diseases and so on. But they had been there for, who knows, maybe 10,000 years, living in this unbelievably bleak, icy environment, cold, windswept. And they were so successful. One shouldn't say, oh, they were primitive or anything like that. Their technology was. They had very simple technology, but obviously it worked very well to last so long. But I think the shock of this taught Darwin a lesson that other people didn't learn, which was the difference between humans and animals actually isn't that great. Like we like to think it is. We like to think that we're so much better and everything, but he'd seen places where a human being slept in a hole in the ground. And he thought, my dog wouldn't sleep in a hole there. And yet a human being did. And he didn't think of them as non-human. He knew these people, or some of them. He knew the three that they brought with them. They were just as human as he was. And so this taught him that human beings aren't just like me and my community at home. That isn't the entirety of humanity and what it means to be human. That's just what I thought. Because even though they seem so animal-like to me, they're just as human as I am. And every educated Englishman knew that his own ancestors were just the same. When Julius Caesar and the Romans came to Britain 2,000 years ago, what did they find? A bunch of naked, blue-painted savages on the cliffs going, yeah. Those were his ancestors. So it wasn't a question of them not being human or being more animals than we are. They're just as human as we are. And they proved that we have many different lifestyles. Some of them are really similar to what other animals do.
Yeah, it seems that he really internalized that the line between man and animal is a really thin one. And I think that would also, in a certain sense, I guess, motivate his work in the origin of species as well, or at least it would be more intuitive to him. When he published his work, what was the reception like? How did people actually take to it? Right now, we kind of take his work for granted in the sense that it is true. But back then, I'm sure the blowback must have been at least serious in some cases.
Oh yeah. I mean, the book was hugely controversial when it came out in 1859. Everyone had heard of some kind of evolution before because many other thinkers had proposed some kind of change of plants and animals. But Darwin's was a different version. It was the one with this single branching family tree and through this process of selection. So it didn't have any invisible natural law pushing it in some direction like others had had. So it was very plausible. But people had a long-standing tradition of thinking any kind of evolution is a really stupid idea and a dangerous idea and not real serious science. That's popular science junk. Serious science doesn't do it. So there was a lot of baggage already around in people's minds when he came out with his theory. Some people could immediately see that, whoa, this one's very different from all the other ones. This one we have to take seriously. Whereas other people just carried on treating it like it was what they already knew as evolution and made fun of it and so on. And they still are. So there was a lot of reaction. Some people were very shocked. A lot of others thought, oh gosh, this one he has a lot of evidence. It's really good arguments. And because of who he was as well, he had a very great reputation. He wasn't a popular science writer or he wasn't an unknown. He was a serious person with serious credentials. So you had to take it seriously, or you should take it seriously. And so bit by bit, he convinced more and more experts that as much as they didn't want this to be true, they didn't like this. They certainly didn't want human beings to be related to animals. But gosh, they just couldn't deny this part. And maybe they didn't want to accept the whole. But bit by bit, all of it was so plausible and so well linked together that they fell like dominoes and people came to accept his theory. So that within, say, 15 or 20 years, the fight was over, which comes as quite a shock to my students nowadays, because what do you know about the news 100 years ago? Well, you don't know anything about it. But people stopped fighting over evolution 20 years after Darwin's book came out. And it's been established scientific fact ever since. How could you do that? How could you convert a world which really hated the idea of evolution and thought there were all kinds of reasons why it couldn't be true and why it was really a horrible idea? And even if it was true, they didn't want to hear about it, didn't want to know about it, didn't want it mentioned. How did such a world get converted to accept that? Well, yeah, actually, that's true. Yeah, life evolves. And because, I think because he was, in a way, he was not attacking people for their beliefs. He was just saying, look, yeah, things work like this, and this. Therefore, things change over time. And otherwise, their beliefs, and particularly religion, shouldn't have been affected by that. And for most people, it wasn't. That they carried on with their religion and they accepted that, oh, right, okay, nature works like this. Okay. We could use some of that nowadays.
How did he convert these thinkers bit by bit? What was kind of like the step change or the kind of narrative that he presented to them that eventually led to this conclusion that, we came from a common ancestor?
He made his case for evolution in general in The Origin of Species. And then everyone was talking about its implications for human beings. And the first book isn't about that. It's just about the general process of how living things change over time and how they're all related. So 12 years later, he published this book, The Descent of Man. And it was then that somehow the whole controversy erupted again, because now it was specifically saying what was implied before. Human beings evolved. And so it kind of erupted again. And that's where all the caricatures of Darwin start. There were no caricatures of him as a monkey man or anything like we see from Origin of Species. For 12 years, nothing. As soon as The Origin of Species appeared, boom, there's an explosion of these caricatures of showing Darwin as an ape or a monkey, or other people's apes and monkeys, because people found the idea laughable. Or even if they took it seriously and thought, well, it's probably true, but they still thought it was funny to draw people as monkeys or apes. But the case what he was able to make was very powerful by showing that anatomically there is no difference between us and the other primates. That wasn't new. People had known about that for years. But given that it's already accepted that everything else has gradually changed from things like it, and there's nothing about us that's distinct physically from all the other living things, then clearly we had to come from the same family of animals, which is true for all other living things. Whatever species you look at, why does it look like this? It comes from this family of things. They all look kind of like that. And that was true for humans. So yeah, it was very shocking and objectionable for some people. But yeah, the evidence by this time was just overwhelming.
He was able to convince not just the general public, but the scientific community. Even some of his harshest critics eventually warmed up to his ideas.
Some of them.
Yeah.
But there's a phenomena that a lot of people have observed, which is that younger people are more open-minded to accepting new ideas and new perspectives, whereas the older established experts usually don't. they're usually very convinced and very committed to things being a certain way. And when some new innovation or new theory is proposed, they usually think, no, that can't work. And so those people usually are not convinced. Darwin did convince a lot of them, but not all of them, of course.
Yeah. When you say that, it reminds me of even Lee Kuan Yew. He thought social media was just a passing fad.
Really?
Yeah. So
Oh, no.
in his last few years of active politics, he thought, oh, Facebook, whatever, it's not. And my guess is probably because that innovation forms such a small part of their life, or is so recent to them compared to the decades of experience they had before. And maybe that might make it hard for people to change their minds.
Well, there's another thing that someone like Lee Kuan Yew at that time of his life, you have to remember that he's seen a lot of fads and fashions come and go.
Yeah.
So actually, it's a pretty safe prediction that when some new thing is coming along that everyone is talking about, everyone's buying this or everyone's doing this, pretty safe prediction that probably won't last.
Yeah.
Because usually they don't.
Yeah.
So some things, yeah, they do last, but none of us have the benefit of hindsight at the time.
Yeah.
But that makes perfect sense, actually, yeah.
And that might explain maybe why there was resistance to Darwin's views.
There was a lot of resistance. But at the same time, I think resistance gets exaggerated because it's more dramatic. And when we hear stories about the past, there's like a struggle for existence or a natural selection there as well, which is the stories that are more entertaining or more dramatic tend to win over the more mundane, true ones.
Yeah. Because they tend to stick in your mind.
Yeah, people like that. So if you tell the story that Darwin came out with this theory and the church was hammering him and it was this huge fight between science and religion, I mean, that just sounds better than actually most people in the Church of England accepted his view within a few years. That's the truth, but it's not nearly as dramatic as the other version. And so the truth never really seems to, and when it comes to history, it's hard to win against these popular stories.
Why did the church come around within a few years?
That's a really good point. The church came around because of the particular type of Christianity we're talking about, which was one where the Bible and the stories in the Bible had never been something that people were sworn to believe in literally, or even accustomed to believe in literally. The Bible was their source of knowledge, but more importantly, it was a source of faith. So their religion was about faith and belief. And whether or not Noah's Ark and the flood story really happened made no difference to believing in God and believing you're going to be nice and go to heaven. That was the core of it. So when geologists found out that, and all of them Christians, and most of them were in the church, they found out that there was never a global flood. This is the generation before Darwin. Yeah, a lot of people objected to that, but it wasn't a deal breaker because that's not how their religion worked. They were not, sworn or dedicated to believing that the stories in the Bible were literally true. So when some of those were shown by science not to have happened, nobody particularly liked that, but it also didn't really matter because it wasn't a deal breaker. So there were a whole series of these that happened with astronomy, showing that the Earth was not the center of the solar system. And then with geology, showing that actually the world wasn't created 6,000 years ago, like we thought. And all plants and animals did not start at once. They've started thousands, millions of times over and over and over again. Everyone, including the church, all came to accept that because it didn't really affect the fundamentals for them. And then Darwin was the last in a long series of those things. Humans descended from apes? Okay. Because they could still believe that God had given people a soul and that the rest of the religion just carried on the same. So that's the answer in short, which is the kind of Christianity they followed at that time. And it didn't really matter that some of the stories in the Bible were not literally true. That was never the point of their version of Christianity. Whereas nowadays, there are a lot more communities who have been told that you have to believe the stories literally. And so obviously, then they hear something in science that contradicts that, then oops, you've got a problem.
Charles Darwin spent 30 plus years writing or working on a book on earthworms. Right? That's the last book he published. That seems really odd. You write about the origin of species, you talk about the descent of man, and now you're talking about earthworms. Why are earthworms so important?
It was 30 years from noticing that worms seem to be very important in shaping the land and the landscape to finally publishing the book on it, which is typical with how Darwin worked. You'd notice something and then it'd take a while to clear the decks and then you move on to the new subject. Earthworms, he noticed that when someone sprinkled, I think it was some ashes on a field, and the ashes are kind of white. Maybe they burned paper. No, it was something else. Anyway, they put this material on the ground, which was just sort of thrown away in a field. And his uncle told him that over a few years, those all vanished. They were all now underground. Just a little bit. The soil had covered them. Like somebody had gone out there with a handfuls and covered it all with soil. And it was from the worms. Because worms dig their little tunnels underground and they take the material into their mouth and they come to the surface and they spit it out. It looks like somebody squeezed a toothpaste tube. You see the little squiggle of soil, little tiny ones. And that's come from underground and put above the surface because it's a pile on top. Well, add that up by billions and billions of times over every square a hectare. And that means that all the material is being taken from underground and put on top. And anything that can't go into the mouth of a worm stays put. So it actually gets buried by them undermining what's underneath and spitting it out on top. And that's how a lot of archaeological ruins get underground. Because worms bury things. So rocks will sink. Darwin put an experimental stone in his garden. And they measured the rate at which it slowly sank. Because the worms are just doing this everywhere. So in the end, when you see a landscape with smooth rolling hills, that's from the worms. Because the unevennesses, the bits that would have been jutting out and jagged, it all gets more rounded from this little action of teeny tiny worms doing a little tiny thing. You see, it's just like the coral reef theory and his natural selection theory. Little tiny actions that in themselves seem so mundane and unimportant. But if there are enough of them and they go on long enough, it can change the entire world. So he showed that worms were not what people thought they were. People thought they were a pest. People thought that they hurt your plants. And his book showed, no, they don't hurt your plants. They eat things like rotting leaves and so on. And without them making these holes in the soil, the soil would become too compacted and we wouldn't be able to grow our crops. So civilization would be impossible without the mundane, boring little worm. So doing that for worms is very Darwin, actually.
Yeah.
And showing that little tiny changes, which in themselves seem irrelevant or trivial, will add up to make huge change. That is pure Darwin.
When you talk about that, the Darwinian idea that little things add up, seems to me in his life he's incredibly productive, but at the same time he was grappling with illness, and his day-to-day looked quite boring and mundane as well. What was his day-to-day like, actually?
As a wealthy man and father of a large family, they have a large comfortable house. They have servants to cook and clean and so on. He had the freedom to do as he liked. So he lived a routine that he chose. He moved out of smoky, polluted London into this quiet, beautiful village in Kent. And there he could do his own routine, which was he gets up early, has a cup of tea, he goes for a walk in the woods by his house. He goes to his study, he does some work. He'll sit with the family, and there's sitting by the fire. There's opening the letters. He has a novel read to him for an hour or two, and he falls asleep after lunch. So every day has exactly the same rhythm. But you see, without jobs and without other kinds of commitments, the family worked according to this routine. And that was what he was comfortable with. That's why he lived like that. But even other people at the time thought that it looks pretty boring, that his life is always like clockwork. Just every day, it's the same. Some people like that. Some people find comfort in doing things always the same.
Yeah, and yet he could publish so prolifically.
It is surprising that someone who was ill as much as Darwin was so productive. A lot of people said that at the time. The poor man he spent years of his life just being sick, vomiting and having all kinds of stomach and digestive problems. And often, he could barely crawl over to his study and do a little experiment or read a little bit. But that also meant that he really valued time.
Yeah.
And that when it was work time, wow, he worked very intensively.
Yeah.
But it's hard to see how that adds up to so many books and so many discoveries.
He had a very strong observational skills. Like, how does one cultivate that kind of observational skill? Or could you give us a flavor of how rich his observational skills were?
Yes, that's a very good point. Darwin once said about himself, "I don't think I'm more intelligent than the average person. If there's one thing I have, it's the ability to notice things that other people don't." I think that's pretty accurate. He did notice a lot of things other people didn't, like the relationship between those fossils and the animals that live there in South America today. And in the case of the Galapagos, he noticed things that everyone else was being shown those same specimens, being shown the same birds that he brought back. So the facts were there for everyone, but he noticed little things that other people didn't. The same with the coral reef theory, noticing that, well, if the island were to subside, it was all there for anyone else to have found. And again, he noticed things that others didn't, particularly with his work in botany and his discoveries with plants that eat insects. You've probably seen a documentary about plants, eating. All of that was discovered by Darwin. It's amazing. People just didn't know that before. They thought that, well, insects just get trapped on those, or it's just bad luck, or it doesn't mean anything. There's no reason for it. And he investigated it and found that they are trapping those insects and digesting them. They actually make a digestive fluid that comes out like stomach acid and drink them up. So yeah, and the earthworms is a classic example of Darwin noticing something that nobody else ever thought of looking at. So he had all of these amazing innovations, and those had the effect of bringing science so far beyond what it would have if he wasn't there. So if you ask, how can one cultivate that? Part of it is clearly innate. Some people are just like that. They just notice weird things that nobody else would ever see was there. It's just background that nobody would notice. But you can cultivate it by being inspired by someone who can show you. So for example, I've taken students into some of the forests in Southeast Asia, and they're Singaporeans. They're from an urban background, and they're not really that used to walking through forests and so just by showing again and again, oh, look over there. Come away from the trail. Let's go over here and look what's under the leaves here. And you start to show something. It starts to open their eyes to the fact that, gosh, there's things all over the place. And without, I guess, being inspired with the example that this exists, that there are things you're missing, without being shown that a few times, how would you know? I've been to the Botanic Gardens and seen people walking by a tree where there was this beautiful tree snake right on the side. It was right there. So everyone could have seen it. No one saw it because they just walked by and they weren't really looking. Or another time I saw a cobra not far from an MRT station. It was on the grass on the edge. People were walking by. Nobody noticed it. I think that's why, because you need to be shown, or I guess to be inspired, to look closer, because there's all kinds of things we're not seeing.
Hmm.
And when we do see them, it's really amazing.
Yeah. Wallace was a contemporary of Darwin, and there's been this idea that he's a rival or somehow he was overlooked. Can you help us set the record straight?
I have spent a lot of time setting the record straight, and I, as a historian of science, I've done more research and published more books and articles on Wallace than any historian who's ever lived. So although people think of me as a Darwin person, I'm more of a Wallace person than any other historian. So Wallace is a fantastic person, and his story is very interesting. But unfortunately, in the middle of the 20th century, his stories began to be retold and to progressively depart from historical reality. So if you read a book about Wallace from before 1960, everything in it will be accurate and correct and true. If you read one from after that, it's almost certain to have absolutely screaming myths of howlers of mistakes, which emphasize things like he's forgotten, he was mistreated or cheated, and things like this. He should be more famous. All of these things about feeling sorry for Wallace. These are, like I mentioned before, examples of stories that sell better than the truth. The truth is more mundane, but that's what historians are supposed to try and uncover and share. But those stories will never outcompete the more dramatic ones of Wallace being cheated or forgotten and, we really should fix this.
Yeah.
Whereas the real history is not as dramatic as that. Nothing nefarious happened between Wallace and Darwin in their own lifetimes and for a generation after their lifetimes. The story of Darwin and Wallace both discovering the same kind of evolution was considered, wow, what an amazing a coincidence, and what an amazing example of things all turning out for the best, turning out well, that these two surprised one another, and that the priority of publishing of the idea was shared. It's considered a happy ending until you get the middle of the 20th century. And since then, it's considered very much not a happy ending. In fact, very sinister. It's something very bad is going on.
Yeah.
And so basically everyone who's ever heard of or read about Wallace today has heard that version of events. And if they hear me saying that actually there's nothing to feel sorry for Wallace about, and nobody who knew Wallace and Wallace himself would have been shocked at this version of events, they think, why are you saying that? How can you say that about poor Wallace? Whoa. That's the story that's fake. And we can see where that story came from in the middle of the 20th century as this victim story gradually grew. So it has nothing to do with the real Wallace. He wasn't a victim. And getting back to the historical truth is the best thing to do for him. He's really interesting. Whereas to retell the sexier story that he's a victim and was cheated, and he really should be just as famous as Darwin and so on. That's not history. That's not what historians do.
Yeah.
That's what fans do.
What were the scientific contributions of Wallace in understanding our world? He was so immersed in Southeast Asia at one point in his career, and he did so much. He even had Ali Wallace that kind of assisted him in his work. So it might be useful to kind of understand, how did Wallace push the envelope of science?
Wallace came to Southeast Asia to be a collector. There weren't that many jobs in science back then, and his family didn't have money, so he needed to earn a living. And yet he loved nature and he loved science. So that was the perfect career path for him, was to become a self-employed collector. So he traveled throughout Southeast Asia for 8 years, and he employed lots of local people. Ali was just the most important and the longest of his helpers. But so Wallace and this army of assistants collected this gigantic number of specimens of beetles and butterflies and birds and little mammals and so on, so that the knowledge of that the scientific world possessed about what lives in this huge part of the earth was hugely increased by all the things that Wallace discovered. We don't even know how many species he discovered. A lot, probably hundreds of things known to science come from Wallace's discoveries. And particularly, he paid attention to what lives where, because it's really complicated. On this island, you've got these beetles and butterflies and birds. On this other island, you've only got some of them. And everywhere he went, there were some things that were missing or some things that were added. And so he wrote a lot trying to tabulate all of this, because all of that is a way of reconstructing the past of life. But how did it get to be the way it is now? It's what we see today are just clues in putting together. So, for example, the biggest discovery of this kind he made, we now call the Wallace line, going down the whole region, and coming closest between Bali and Lombok, where the Wallace line is an invisible line right between them. And you can see right across. And on Bali, the animals are Asian types of animals, Asian families of animals. And over on Lombok, they're Australian families of birds and other animals. I mean, it's a really dramatic difference between these two types of animals. And the islands, the land doesn't seem to be any different. So why weren't they created the same? See, according to the logic of science of his day, well, clearly he could see they weren't created there. They came from somewhere. They're descended from something. And the way that they've been able to move from island to island over time explains why they are where they are. And then in the midst of all of that, he came up with his own version of evolution by natural selection, which is enough credit, I think, for that any other human being would be lucky to have such accomplishments on their list. So yeah, he was hugely successful in terms of his discoveries and his insights. And by the time he returned home, all of that collecting, it actually earned him a lot of money. And so for the first time, he could live as a Victorian gentleman, which was what his father had been. And the association with Darwin was the best thing ever to happen to Wallace, because Darwin's book had come out while Wallace was still in Southeast Asia, a book that had taken Darwin 20 years of work, of reading, experimenting, and so on, to create a work with so much evidence that it actually did convince the world that evolution was true. And Wallace had thought of the same part of the filtering process. But there are very many other parts of Darwin's theory that Wallace hadn't thought of yet. He hadn't had time to think of all those things, if ever. So Darwin was hugely famous by the time Wallace gets back. And Wallace is associated with this. He's a player. He is a member of this community, of this breaking new revolution in science. So he's got it made as far as he's concerned. He went from being an obscure collector that few people had heard from to being someone that the magazines and newspapers can mention his name and people know who that is.
Well, my last question for you, what is that kind of one piece of advice that you always give to your graduate students?
I think I give lots of pieces of advice. One of them, I think, would be to pursue your passion and your interest, even if it's not fashionable. It may not be the thing that everyone else thinks is really hot and interesting right now. But if you follow what really interests you, you might go really far.
With that, thank you, Prof, for coming on.
Oh, thanks for having me.
Thank you for listening to today's episode. If you are watching this on YouTube, please consider subscribing and turning on notifications for whenever new episodes are out. If you're on Spotify or Apple, it would help us greatly if you could leave a 5-star review on those platforms. Once again, thank you for tuning in to the Front Row Podcast.